In this lesson, we're interpreting key features of linear, quadratic, and exponential functions. These are for students who have taken Algebra 1 and Geometry. So this is a readiness lesson for students going into Algebra 2. So it will be pretty much an overview of interpreting the key features of these functions. So let's go ahead and get started. For example 1, we have a graph here of a linear function. And it says the graph below represents the number of tickets that a theater must sell in order to generate $350 worth of revenue from ticket sales. And so we can see that from our y-axis we have the children's tickets, and on along our x-axis we have adult tickets here. And I've already given you the answer to the first one. It says, what is the x-intercept? And that is 70, and that is right here. So where the graph crosses the x-axis, your y value has to be 0. And what does it represent in the context of this problem? When 70 adult tickets are sold, because that is our x value here, 0 tickets must be sold to get a revenue of $350. Let's look at B. It says, what is the y-intercept? What does it represent in the context of this problem? So our y-intercept, of course, would be where the graph crosses the y-axis. So that ordered pair is 0, 140. And what does this represent? Now we're looking at the children's tickets. So when 140 child tickets are sold, 0 adults tickets must be sold to get that revenue of $350. All right. So for C, it says, what is the slope and what does the slope of this graph represent? So I like to use rise over run, just counting the spaces instead of using ordered pairs if I have a graph. And so I'm going to pick these 2 points at the bottom here. I'm going to pick this ordered pair. That would be 60, 20. And this ordered pair right here, the x-intercept at 70, but I'm just going to count the spaces. So if you notice for our y-axis, this graph is going by tens. And so I'm going to start here and count down. 1, 2. So my rise would be at -2. I'm going to go over 1 space. And so my run, well, actually my rise would be -20 because it's going by tens. And so my run would be 10. And so my slope, rise over run, that would be -2 because 20 over 10 reduces to -2. And what does this represent? Well, for every 2 less child tickets, 1 more adult ticket must be sold to reach the revenue of $350. Let's take a look at example 2. We're interpreting key features of a linear function using a table. It says Alyssa is painting and selling artwork to raise money for a road trip. She has $75 to spend on enough art supplies to last her through 12 paintings and plans to sell each painting for $25. So let's look at part A. It says, what is the rate of change and what does it represent in the context of the problem? So think rate of change, think slope of the line or the slope of the graph. And so if we're looking at the rate of change here, it would be $25, and it represents the cost of each painting. And what you can do, you can pick your 2 ordered pairs. So here and here, and I could label this x1, y1, x2, y2, and plug it into my slope formula. So y sub 2 minus y sub 1, that would be -25 minus -50 over 2 minus 1. And that double negative is a plus, right? So -25 plus 50 will give me a positive 25. 2 minus 1 is just 1. So the rate of change would be 25, and I just used the slope formula, and it represents the cost of each painting here. And B, what is the x-intercept and what does it represent in the context of this problem? So remember, x-intercept, your y value or your output has to be 0. So my x-intercept would be right here at 30. And it represents the number of paintings she must sell to break even. Profit equals expenses, where loss ends and profit begins. And so right here, This is where she's, we could say, in the hole, where she's, because she had to spend money on her supplies, right? So she had to sell 2 paintings in order to make, well, 3 paintings in order to break even. And so this is where she starts to gain profit here after selling 3 paintings. For C, it says, what is the y-intercept and what does it represent in the context of the problem? And so if you notice here, we do not have a 0 for our x value, right? But if we keep going, right, if this is at 1, let me just erase some of this work here. If this is at 1, independent variable is at 1, and our profit is at negative 50, we see that it is decreasing by 25, right? So if our x, our input is at, not an input, our independent variable is at 0, then what would be the pattern for our y value? It would be at negative 75 because it is decreasing by 25, right? So that y-intercept would be 0, negative 75. This represents how much money she has to begin with, or Alyssa has to begin with. When 0 paintings are sold, she's in debt $75 from art supplies, and so she's at negative 75. So she needs to sell some paintings, so at least 3 to break even. Let's look at D. It says, what is the domain of the function? What does it represent in the context of this problem? So remember, your domain is you're using your independent variables, so it would be these values here. And so that is from 0 to 12, or x is greater than or equal to 0, but less than or equal to 12. We have interval notation here, showing that we're including that 0 and 12, where x is all whole numbers, and it has to be all whole numbers because we're talking about paintings here, right? So it is 0 to 12 because it says supplies to last her through 12 paintings. So although this table here goes to 4, the domain would be 0 to 12 because she has enough money. She has enough. It says she has enough art supplies to last her through 12 paintings. So the domain represents the number of paintings that she could actually sell before she runs out of her art products. So we've analyzed this table here. If you didn't quite understand something, maybe pause the video and just analyze the questions and the answers here just a little more. Let's look at a quadratic function graph and interpret the key features of this particular graph here. It says Aaron shot a bottled water rocket from the ground. A graph of height over time is shown below, and so our y value here is represented by the height, so our y-axis, and then our time is represented by x. Part A says identify the x-intercepts, again, where that graph crosses the x-axis, so here and here. So that would be 0, 0, and 5, 0. After how many seconds did the rocket hit the ground? And so that would be at 5 seconds because the rocket went up and then it went down, and our total time here where it stopped was at 5 seconds. Let's identify the y-intercept. It would be at 0, 0 because that is where the graph intersects the y-axis and also where it starts. It says at what height, for D, at what height did the rocket launch? Well, it launched at 0 meters. It launched from the ground because it started out at 0. All right. The next one, it says estimate the vertex, and so remember the vertex is the highest or the lowest point on the graph, so that would be here. So that would be about 2.5, 6.25, so right here. All right. So estimating here, we're not exact. The next one, it says, is the vertex a maximum or a minimum? So that graph goes down, right? So this is the highest point on the graph, so that would be a maximum. And next one, identify the axis of symmetry. That is the x value of the vertex, right? So that would be x is 2.5. So axis of symmetry is 2.5, and you could actually remember it cuts the graph in half equally. So if we draw a line here, it should cut the graph in half equal. So axis of symmetry, x value of the vertex. And last, it says after how many seconds did the rocket reach its maximum height? And so that would be at 2.5, because this is our maximum, and our vertex again is 2.5, 6.25 approximately. And so that is the highest point. So the maximum height is 6.25, but how long did it take it? 2.5, because that is our time there. Now we have another graph here of a quadratic function. It says a graph of a bungee jumper's height above the ground over time is shown below for the first jump down and back up. I would like for you to try these problems on your own, so go ahead and pause the video and try this example on your own here. Alright, so go ahead and check your answers. The y-intercept is 0, 190. From what height does the bungee jumper make his first jump? At 190 right here, starting. The vertex here, lowest point on the graph, 3.5. So you maybe had to approximate it, because hard to be exact here. It has a minimum because that is the lowest point on the graph. Axis of symmetry, x value of your vertex at x equals 3. The lowest height for the bungee jumper, that is the y value. All right. When does the jumper reach the lowest height? So how much time? In 3 seconds. So you're still looking at that vertex. Why are there no x-intercepts for this situation? Well, the bungee jumper shouldn't hit the ground, so that's a good thing. If it hit the ground, that would not be a good thing, right? The domain, since we have these endpoints here, right? We have, it starts here at 0 on our x-axis, and it stops at 5, and so we have those closed brackets there to include it. What is the decreasing interval? So it goes from 0 to 3, so it decreases. Remember, we read from left to right. So decreases here, and it stops here, so from 0 to 3, and it is increasing up here, so from 3 to 5. So hopefully you got them correct. If not, hopefully I was able to explain it just a little bit more for you. Let's take a look at our last example here. We have an exponential function, we have a table as well as a graph. It says, imagine you are performing an experiment in science class in which you start with 100 bacteria, and the amount of bacteria doubles every hour. So that doubles tells us that that is an exponential function. And it says this situation can be modeled using the following function. So number A, not number A. A, it says, what does T represent in the situation? So what do you think T represents? We have hours, and we have the amount of bacteria. So hours, that is the number of hours since the experiment began. B, what does B of T represent in this situation? So we have B of T here, and that is represented by the number of cells in the bacteria population. And so we have our time here, time it takes, and then this is the number of cells each time. So 100, 200, so it doubles every hour. Let's look at C. It says, look at the equation of the function. Where is T located in the equation? It is the exponent right here. D, look at the graph and the table of values of the function. What is the y-intercept, and what do you think it means in this situation? So y-intercept, remember x has to be 0. So where do you see 0 for x? That would be here. So our y-intercept is 0, 100. This means that at the start of the experiment, there are 100 cells in the bacteria population. All right, and last E, it says, look at the table of values for the function. How are the values b of t changing as the value of t increases by 1? So if you notice, it increases by 1 for our value of t. What happens? T increases by 1, b of t is multiplied by 2. So 100 times 2 is 200, 200 times 2 is 400, 400 times 2 is 800. And so we get the pattern there, which is why our common ratio is at 2 right here. And our initial value is 100. Remember, the initial value is your y-intercept, so that would be your A, which is the initial value, and B would be your common ratio there. We've reached the end of our lesson. I want to thank you for learning with me. Some related videos are key features of linear, quadratic, and exponential functions. That is where you get more of the basic overview of the functions. In this video, we were interpreting what those key features mean. We also have intro to quadratic functions as well as constructing exponential functions. So those are some related videos. If you haven't already, please like, comment, share, and subscribe. Also, click the bell to be notified when I post new content. And once again, I want to thank you for learning with me.